Hello everyone. I find out some students or many students have little misconception about proof by contradiction. Here's the question of number one, and prove the following logic statement by logically true if proved by contradiction. So typically it's like the problem is like you only get a logical mistake is like true only in special cases. Okay, that's not true. Proved by contradiction. For example, many of you follow this logic. So, okay, it proves false, and then that's all correct logically. But then in the middle, you will find so for p is 0, and that is true. That is implicit implication logic. And for q equals 0, and that must be true always. Therefore, you follow all these steps. You say, well, okay, if that's the case, and this is true. Therefore, it proved by contradiction. But this is not really a contradiction. Okay, this only says, okay, this is not a total contradiction. This only says that the statement can be true if q equals 0, p equals 0. And that's your derivation is perfectly correct, but that's not proved by contradiction. Okay, what you have to do, what you need to do is you must prove that in any f value p, q, r, the statement is always true. Okay, so here is one version of proof by contradiction to the same question. So if you want to prove this to be true by contradiction. So then you suppose it equal to 0. And then look at the logic truth table of implication logic. If that is 0, there's only one row in the truth table. This is true, that is false. So you must go from the assumption to say only when this is true, which is the first part, and then that is 0 and that is false. So then from here you immediately logically derive these two. Okay, and now from first one, it's an and, it's conjunction. So conjunction only true if both of these are true. Therefore, so P and Q must be true, and that must be true. So the second part must be true because that's the and. So derived from here, and so then derived from here, and this to be false. Okay, this to be false, and the P must be equal true, and that's the only case. So derive from here, and from here. Third step. So then we go further. They can further. Now let's see. Suppose Q equal to 0. Suppose. Okay. So then you can suppose Q equal to 0. So then from this part, Q equals 0 from this part, then Q equals 0 and Q equals 0, and from here P equal true from above. P equal to Q is 0 and T is true, then you will have 1 implies 0 equal true. That's false. Then that's a contradiction. Okay, contradiction to what? To the implication logic. That is a contradiction. Okay, so then it can also lead to another contradiction that if you have Q equal to 1, okay, to 1, and then you look at this part. Okay, you look at this Q equal to 1, this one, and look at this part Q equal to 1, and from here you have R equals 0. That's nailed there, must be equal 0. So then Q equal 1, R equal to 0, and then 1 imply 0, and then you have 1. So then that is also a contradiction. So in other words, here see, I just told you, this is not just a special case, because if you say it's true, if you say it's false, and then from logically step by step you lead to a conclusion. Basically you conclude, you contradict to yourself. So that is proof by contradiction. Hope this helps.